I hope you all are fine, safe and healthy at your home. So let us start our today's session. In our today's session, I have brought the study of physical properties of non-metal. As you all know that in the previous session, we have completed the physical properties of metal. So in our today's session, we have to discuss the physical nature of non-metal. Okay. So we will discuss all the points in detail. See the first point which I have written. They occur in solid, liquid and gaseous form. As I told in the term of metal, so I have told most probably they occur in a solid form, but few exceptions were there which I have discussed already. Those were in the soft in the nature. But here I have written they occur in the three forms: solid, liquid or gas. So solid form, simply we can say sulfur molecule, that acid, and P4 that occurs in the form of solid. Okay, sulfur, that is especially, this is yellow solid. And liquid, like we can say liquid is bromine. Bromine is a liquid non-metal. And suppose we talk about the gases, like all the gases like O2, N2, Cl2, Br2, okay, and all the non-metals, they occur in the form of gas. Okay, so this is the main quality of non-metals. Non-metals, they occur in a solid, liquid or in the gaseous phases. Okay, now they are non-lustrous. Normally it is to be said that non-metals are non-lustrous. Against it, metals were lustrous, means they were shiny. But here I am telling they are normally non-lustrous, but here the exception is to be there. Iodine is the non-metal which is lustrous, which produce shine. Okay, that you must know that. Okay, now the next property, they are non-sonorous. So you must know that whenever the non-metals, they occur in the form of gaseous, liquid form, and solid, they are not hard solid. So normally they will not be able to produce loud sound on beating with a hammer. So that's why these are non-sonorous in the nature. Okay, now the next property, they are not malleable. Not malleable means simply that you know that gases or the liquid, they cannot convert into a thin sheet on beating with a hammer. Okay, so you must know that all the non-metals, they do not convert into a thin sheet. So that means they are not malleable. And the next one, these are not ductile. Simply you can say these are neither malleable nor ductile. Okay, but here in the case of ductile, I will tell you few examples. Like ductility means they can convert into a thin wire. Okay, so thin wire, few examples like the carbon fibers we are using in mat or the carpet. Okay, carbon in the form of fiber, their fibers are to be made for their purpose. Okay, so carbon, it is a form of non-metal that can occur in the form of ductility. Okay, rest others non-metals are not ductile, that we must know. Next, these are the bad conductor of heat and electricity. This is a normal property that we must know about the non-metal. But the metals, they were the good conductor of heat and electricity. But there were one exception. Lead was the poorest conductor of heat and electricity. But here, there is also one more exception in terms of non-metal, graphite. Graphite, it is a allotropic form of carbon that we will discuss in a next chapter in detail. Graphite, it is a good conductor, that we must know that it can conduct electricity. Okay, with the help of different experiment I will show in the next lecture. Okay, but here you must know graphite, this is the allotropic form of carbon which is non-metal, and this becomes the exception of this property. This is a good conductor of electricity. Now normally they have low density. Except this metals have high density, they have low density. Now the next is they are electronegative in the nature. As metals were electropositive in the nature, they are electronegative in the nature. So let me give you the one example, like chlorine. Its atomic number is 17, configuration 287. Okay, so to complete its octet, it will receive one electron and it will acquire one negative charge, and its configuration, it becomes 2, 8 and 8. Is it clear that you must know that? Let's take the example of oxygen. Atomic number 8, configuration, this is of 2 and 6. So it will receive 2 more electron to complete its octet. So oxygen 2 negative and now 2 8. This is the complete electronic configuration. Okay, so in this way, as all the non-metals, they have to receive electrons to complete their octet, or simply you can say to acquire a noble gas configuration, so they become electronegative in the nature. Okay, now the next point, they are less reactive. Normally it is to be said that all the non-metals are less reactive in the nature, but here you must know that phosphorus, it is a non-metal which is highly reactive. Okay, it is used on the matchbox or on the matchstick. Okay, so you all have seen on the simple rubbing. Okay, simple rubbing, on rubbing it can cause fire, can cause fire. So simply we must know that that is highly reactive non-metal, but rest of the non-metals are less reactive. Okay, so these were the properties which I have compared with a metal and I have explained in a proper way. I hope you all have got it, all the physical properties of non-metal. That's all for today's session.